Okay, 7-7 transformations. You might have to pause this every now and then to get these definitions down, so pause it as you need to. So a transformation is a change in a figure's position or size. Some examples you might think of are a Ferris wheel. It rotates, but it never changes sides, but it rotates around. Like a water slide. When you go down a water slide, you don't change position. You might change position as far as on the water slide, but you just slide down it. You sort of stay yourself, and you definitely stay your same size. So a water slide would be an example of a slide, excuse me, or translation. And then another thing you might think of is, excuse me, I'm sorry, is a mirror image. And that would be an example of a reflection. So again, like I just kind of said, a translation is just when a figure slides along a line without turning. So a picture of that, let's draw kind of a right angle, and then let's put an arrow going up this way. This is the way that triangle is going to slide. So it's not going to change, and do your best to draw kind of the same shape. Not going to change size or shape. It's not going to turn. It's just going to slide along a line. And again, pause as you need to write down definitions. A rotation turns a figure around a point that is called the center of rotation. So if we drew a triangle, let's put a point right here. That's our center of rotation. And if this triangle rotated, then over here it might kind of look like this if we rotated it again. And I'm approximating a 90-degree rotation here. And then you'd have another triangle there. So it started here, it rotated to there, it rotates to there, it rotates to there. Now it would stay the exact same shape and size. It's just hard to do that freehanded. So just do the best you can on your drawing. A reflection, and again, pause when you need to write down definitions. A reflection flips a figure across a line to create a mirror image. So what that would look like as a drawing, maybe we draw a line of reflection. I'm just going to use a dotted line. And if I had, I'll use a triangle again. If I had a triangle on this side and I reflected it over that line, it would look like this. Some people talk about this as if you folded on this line, these points would line up, these points would line up, this point or vertex would line up. So when you fold it on a line, everything would line up on the line from the line of reflection. And then this is just some more vocab here, the word image. The resulting figure, so when I reflected this from that side to this side, this would be the resulting figure, or sometimes it's called an image of the original figure, is congruent. So it's always going to be the same size. So up here when we're rotating our triangles, they stay the same shape and the same size. All right, go ahead and flip the page. Pause if you didn't get some of that down. All right, when we do transformations on a graph or a coordinate plane, we might reflect about a horizontal axis. Remember, horizontal is this way. Vertical line is this way. Only one of the coordinates changes. So let's look at this one. This is a reflection across the y-axis, and this will definitely help you with your class assignment for tomorrow. So a reflection across the y-axis, the x-coordinate goes to its opposite. So this is the original. How do I know this is the original? We talked about this on Evaluate. Look at the difference in this A and this A. Okay, this A has this little mark, kind of like an apostrophe, and that is called A prime. And it is the new figure. So this one is the new. So we took A, which is 3, 1, 2, 3, comma 1, and we reflected it across the y-axis. Notice, it says up here, the x-coordinate goes to its opposite. So instead of this being 3, comma 1, it's now negative 3, comma 1. So we reflected it across the y, which makes the x go to its opposite. The y stays the same. When you reflect something across the x, the y-coordinate goes to its opposite. So this is the original. Again, remember, this one is the new. because it's B prime. It has that little mark, like an apostrophe after it. So the original was 2, 1. The new is 2, -1. The y value changed. When it goes across the x, the y value goes to its opposite. The x value, the right and left value, stays the same. Okay, let's look at another one. Here we are translating points and indicated number of units to each coordinate. So for left and right, you add, and I'm going to say or subtract. Left and right, you add or subtract. So right would be, you're going to add units on, left would be you'd subtract. To the x-coordinate, because the x-coordinate is what tells you to go left and right. For a translation up or down, you add or subtract units to the y-coordinate. So if it's going up, you're going to add coordinates on. If you're going down, you're going to subtract coordinates off. So what this says is point 1, 4, over here is right here. It is going to be translated 3 units down. So 1, 2, 3. Now that point is 1, 1. Again, P prime. That's the new point. So that is 1, 1. It is right there. Only the y value changed. Y is the up and down value. When we put this 3 units down, we took 3 off of the y. Again, I'll be using this on your classwork tomorrow. So you can see kind of them doing math in here, and I think I've seen problems like this on Evaluate as well. So this is 1, it was 1, 4, but we're going down 3 units, so we're going to add on -3, or you could just think of this as subtracting 3. 4 minus 3 gets you 1. Okay, down here at the bottom of your page, we are going to draw and label the image after the reflection. So let's try to do this math. So when it goes over the y-axis, the x will go to its opposite. So our new P prime point is going to be 1, 2. And then let's check ourselves with a graph. If you ever don't have a graph, you can always make one. So 1, 2 would be here. It says and label. So this is our new P prime. Its coordinates are 1, 2. Did that reflect across the y or over the y-axis? Yes, it did. So it worked mathematically, just changing the x value when you go over the y. Let's look at this one. Again, draw and label. Here's the original. A is -3, 5, 4 units to the right. So that is going to add 4 units to the x value. So the x value right now is -3. So our new point, A prime, if we add 4 to this, that's going to be +1, 5. Let's check it with the graph. It should be right. We know that you add 4 to x to move it right. So 1, 5 would be right here. Is that point 1, 2, 3, 4 to the right? Yes, it is. Label it. That is your new A prime. That prime indicates a new point. Okay, if you would flip your paper over, and on the back, I want you to write this down. I'm going to pause here for a minute. I want you to write all this down on your paper right now and then restart this video. Okay, so you should have written all this down, and this is the last little thing that we have to talk about. Sometimes it may ask you to do a 180-degree rotation around the origin, which is the 0, 0. When you rotate something at 180 degrees, the square here was in quadrant 1. When I go 90 degrees, that would make it down here, and I'm going 90 degrees clockwise here. So 90 degrees clockwise, where the clock would go, would put it down here into quadrant 4. Another 90 degrees clockwise would put it down here in quadrant 3. Every point here is positive, 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 positive. Every point over here is negative, 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 negative. So that's what I'm saying right here. So what this tells us is that any point that you are rotating 180 degrees, you just change the coordinate, let's say coordinates, to their opposite. So if they were positive, you make it negative. And if they were negative, you make it positive. So try to rotate. I'll do one with you, then I'm going to have you pause and see if you can do these. So 4, 3, they're both positive. We just need to change the coordinates to their opposite. So the new point here would be -4, -3. What we probably should have done is says that this was point A, so our new point would be A prime. Okay, let's make this B, this C, and I want you to pause the video, find B prime and C prime, and then start it up again to check yourself. Okay, so if you did those, the new B, the B prime, you do the opposite. The opposite of -2 is 2. The opposite of 7 is -7. That would be if we rotated this point 180 degrees. And C, 9, -1, or the C prime, the new C, would now be -9, 1. And I think I said earlier that we were rotating clockwise, and this I did clockwise, but let's think about this. When you rotate 180 degrees, that's half of a circle. So even if I rotated this way, 90 degrees would be there, and another 90 would be here. So 180, when you're talking about rotating something around an origin, doesn't matter if you go clockwise or counterclockwise, it's always going to be the same. So that is it for today. Thank you for watching.